So hello everyone. Today I will be going to talk about Kubebuilder, and we will deep dive into it also. So let me take a moment to introduce myself. So my name is Oshi Gupta, and I am currently working as a DevOps engineer and technical writer at Cloud Technologies. I have also been an LFX mentee for CNCF Keyworno project and a CKA certified. And apart from this, I love playing badminton as a hobby. So these are the topics we will be going to cover. So before that, how many of you are familiar with Kubernetes, like custom operator, and have build it? We'll be discussing a brief overview of Kubernetes operator, CRDs, reconciliation loop, and how we can write our own operators from scratch. Then how Kubebuilder simplify our work and how Kubebuilder works, and a small demo video of working of Kubebuilder. So Kubernetes operator, it's like an application specific controller. So whatever the things the native Kubernetes resources cannot do, so for that we build our own Kubernetes custom operator. So for that we build custom resource definitions, which have all custom resource fields, like what type of fields it's going to be, what fields it's going to be. So all this gets included in our CRDs, that is custom resource definition. And also we have to build our controller, which runs our reconciliation loop to maintain the desired state equal to current state. So this particular term we are all familiar when we work with deployments and replica sets. So this diagram is pretty self-explanatory, but whenever a user creates a custom resource, so operator execute that particular YAML manifest and create the resource, and whatever the fields have been defined in the custom resource definition, according to that your object gets created. And if there is any change in the object, in that particular object, so that operator runs a controller for which has your business logic to maintain the current state equal to the desired state. So it's like an infinity loop which is run continuously. So the next is why and when to use Kubernetes operator. So as I have told you, it helps in extending the functionality of Kubernetes API. Whatever the things you can have to do as a manual dependency, that you can transform as in automation way. Also it's helps in backup recovery from failures and all these things. So let's take an example of a stateless application. Let's say deployment where we deploy 3 replicas of pod. So when we deploy the new release or want to scale our applications, or any one of your replica pod gets deleted, so automatically a new one gets created with the to maintain that desired state equal to current state. That deployment controller looks take care of. But let's say I have a stateful applications where I am just going to deploy a Postgres database cluster. So here I have to do so many things. I have to do initial configuration, I have to do some leader election and all these things, so that data can be consistent. So for this type of thing, I do need a custom operator, because Kubernetes native resources cannot do it. If I tell you example, I was trying to deploy a Postgres DB, fortunately on a staging setup. So I have deployed a stateful set, exposed it via service, PV, PVC, and all these things. But one fine day, one of my cluster node gets in failure state. So because of that, all my DB data got lost. But if I have implemented with the help of some custom operator, so this I have my data backup, and I should have easily recover also. But I was not aware of that, so I have to face that data loss. So this is how your Kubernetes object fields look like. First we have to specify object API version, what kind of object we are going to build. And inside like metadata, we specified some metadata fields like name, labels, namespace, and all these things. This last two are like very important, which like helps in like maintaining our like desired state equal to current state. Like in spec of an object field, we define whatever the desired state we want, and whenever that object is gets created, status show like what is the current or observed state. As you all know that there are like core and named API groups. So how to write on operators from scratch? Like as I have told you, like Kubernetes operator has custom resource and like your business controller logic also. So for CRDs, we have to like implement our API type, like what type of API we want, schemes, like we have to register it with the Kubernetes, like this is going to be a particular CRD and all these things. And in the controller, we have to like, these are like all client Go, part of client Go library, where we have to inform like client set informers, and we have to create our own reconciler loop, event handling, and all these things. Apart from this, if we want to create an admission webhook also, that also we can like implement it. And then the last thing is convert all these things in a YAML manifest and deploy it in your cluster. Or like build a Docker image of it and put it on your Docker registry. I think most of you have seen this particular diagram, but I'll just brief overview about it. Like whenever Kubernetes object like gets created, informer with the help of like reflector keeps a watch on the Kubernetes API server, so that if that any particular custom resource object gets created, it will like put it in a queue, and the informer like pop it out and put it in a cache store, which also has indexing function in it. So basic, which helps us to like take out the desired state and current state of the object whenever we want to like update a particular object. And then with the help of resource event handlers and all these things, whenever your some event handlers event occurs, so event handlers will put your object in a work queue, and in the process item, your business logic controller reconciliation loop will run to maintain the desired state and the current state of the object. But I don't want all these things to implement by myself. Like I don't know like what is this client set, informer, and all these things. So there are like some tools which helps in like writing custom operators, like operator framework, Kubebuilder, meta controller, and KubeOps, and like there's a huge list also. So we will be discussing about Kubebuilder. So this is an open source project maintained by Kubernetes 6 API machinery. It is an SDK written in Golang, and also it uses controller runtime and controller tools as a sub-project, and it gives a DIY like from scratch experience, like it's simplified, and it scaffolds the project structure for us, and we only have to write our own API definition and on controller. So as I have told you, like Kubebuilder depends on controller runtime and controller tools. So controller runtime will help us in like downloading the shared dependencies. Like it will provide us an SDK for creating controllers and webhook, and the controller tools will help us to generate the manifest from all the things what we have like defined in the API schemas and all these things. And also controller tools gives us a controller gen like binary tool and all these things. So controller runtime, as I have already told, like it gives certain things like manager, controller, reconciler loop, and all these things. So as we know that Kube controller manager has all the abstraction of different controllers in it. Similarly, Kubebuilder also has a manager in which we can like group different controllers. We have to like create a controller and edit inside the Kubebuilder manager, and after like proper testing and all these things, we can like install it in our Kubernetes cluster with the help of this manager. So controller tools I have already told. So to summarize, like whatever the from scratch versus like Kubebuilder experience, there's going to be a main.go file which will start your manager in the Kubebuilder, which is like helps. So this is done. Kubebuilder scaffolds all these things like API type, scheme register, and all these things. Controller tools like helps like as I told you, like it helps in generating the YAML files. So it like encapsulate that, and controller runtime helps us in like all like building the APIs, schemas, and all these things. So as a part of our demo, we will see how to scaffold a basic Kubebuilder project, uh, what is the structure of that particular project, and how we can like create a custom operator with resource and logic, and then we will like apply it in the Kubernetes cluster and test it out. So I have a demo video for this, so I'll just play and like we will discuss about it. So in this particular demo video, I'm just going to create a demo resource kind object, which will be having a API version of demo.demo.kcd.io with version v1. And inside the spec, I'm giving a particular name field and namespace. So whenever this user will create a CRD, the demo resource controller will keep a watch on it, and it will then create a object of pod object with the same name whatever the demo resource object name has been there, and inside that pod object will run a nginx container in it. So let me like play this particular video. So this is how a basic workflow should be there of like scaffolding a project and like building your own Kubebuilder operator. So as a like first we have to install Kubebuilder CLI. So as a prerequisite, you have to install Golang, and with the help of that Golang, Kubebuilder CLI will be installed. A Kubernetes cluster so that you can like test it, and if necessary Docker, so that after testing out, if you want to put it on your Docker registry, so that you can like put it. So Kubebuilder init will like scaffold the project, like it will create some main.go in the CMD directory and all these things. Then with the help of Kubebuilder create API, you can like create your own custom API, like what particular domain and the name of the particular object and all these things. And all these things will be like will be there whenever like you will execute these commands. You just have to like insert your custom controller logic and test it out, and with the help of like makefile, where you will have like certain make targets which will generate a YAML manifest for you, and then with the help of some make commands you can like install it in your Kubernetes cluster. Similarly, like you can implement webhook also, like putting some logic and deploying with the help of makefile. So first we have to create an empty directory where we will like initialize this Kubebuilder init command with domain flag and the repo flag. So domain flag basically it will be a like part of your API group. So you can have different APIs as a part of like one group. Like we have storage.kts.io for storage classes, rbake.authorization like .kts.io for rbake. So like to avoid the naming conflicts, we can like include this domain flag. So this will create all these things like CMD directory, config directory, and all these things. Inside the CMD directory, you will have your main.go file, which will like, it's like an entry point for you whenever you will run your controller. So it will like first start the manager, in which you have like already registered your controller. So with the help of that, your controller will get started. This is like how a Makefile looks like. Like there are like manifest target, generate target. Manifest target will help you to generate the CRDs for it. Uh, uh, then you can like test it out, build it. There's like so many targets in it. Like there is a install target in it, which will help you to install that particular CRD inside your cluster. Similarly, it has like a Docker build and a Docker push target also, which will help you to deploy it on your Docker registry. So this is all is done with the help of customized tool also. So as I have told you, like Kubebuilder will give you a basic structure also of your CRD. So with the help of customize, whatever the targets are there in the install and all these things, customize will run and install it in your cluster also. So just go backward. So inside this API, is we will like create a group of like v1 version. So this will generate these two files of whatever the object we are like name of object and all these things. Inside this particular demo resource underscore types.go file, we can like define our API definition. Struct is already there, so we just have to fill our API definitions in it. Like with the help of this scheme builder, we can like register this our APIs in the Kubernetes cluster also. So for the controller, I'm just like for the definition, I'm just like putting this particular two fields inside the demo resource spec struct, and for like to maintain the to run the reconciliation loop in the status field, I will just have this name field in it. Now, as I've like run the Kubebuilder create API commands also, so it will like create a controller file also for us, so which will help us have our like logic inside this particular file. Here we can like implement our logic, like I have told you, like we will create a demo resource object, and from there Nginx pod will be like created. So also we do not have to like worry about RBACs and all these things. So Kubebuilder generates all the RBAC permissions and all these things inside this RBAC folder also. So if we want to edit, we can like edit it, but Kubebuilder gives us that particular utilities that you go and build your own controller. So this is like code implementation. This is a CRDs that like get generated when we run the make command from the Makefile. Like here the like the kind and all these things, all the description like you can see here. Now after like creating all the CRDs and all these things, I'm just going to install it in my Kubernetes cluster. So it will like find the kubeconfig file inside that .kubeconfig directory or .kube directory, and it will like install this all these CRDs inside that particular Kubernetes cluster. Now if I execute kubectl get CRDs commands and all these things in my cluster, so the CRDs have been like installed, and all the API resources also have been like installed in it. So okay. So Kubebuilder also gives us like a basic object file also, in which we can like custom resource file in which we can like edit our own fields according to our definition. And to run it locally, we can just use this make run command, which will like run this particular controller locally. So it will like execute go format, go wait, and all these commands. So after like running, this is how your outputs look like. Whenever your custom resource object gets like created, it will like enter in the reconciliation loop, and it will like create a pod also on the basis of the definition whatever like we have specified. So here like my nginx pod also has been like created on the basis of this object creation. So here you can see that like whatever the Docker image I have been like provided and all these things, my nginx pod has been like created. So after like proper testing and all these things, you can like execute make docker build command and all these things also, and like log in into a Docker registry to push it on your like Docker hub also. So apart from that, so if I talk about some real use cases, so Kubeflow, which is like a machine learning toolkit for Kubernetes, uses this Kubebuilder for building this MPI operator, which is a training job. Apart from this, Kubebuilder, which is an application delivery platform, also uses this Kubebuilder for building this particular tool. So these are the like references which I have used, like CNCF operator white paper, one of the Kubebuilder docs, one of the videos from KubeCon controller runtime, and all these things. Yeah, so thank you.